Hi, good morning. This is section 12.7. We're going to go over translations and dilations of a graph, which is like a bunch of crazy mathematical language. So we'll just get started with something you guys know, which is vertex form. We left off with class talking about how A was like a multiplier, x minus h squared plus k, where h and k were representing your vertex point. This was the h was the x coordinate of the vertex and k was the y coordinate. So what I did below this was just show you what if we had a parabola that was centered at 0, 0. Just to show you guys what a graph would look like. It's going to end up being something like this, and we're going to pull it up on the graphing calculator. And basically throughout the lesson we'll just manipulate the graph by switching the values of h, k, and a. So if you look at this equation right here where my cursor is, if I have an a value of 1 and then my h and my k are 0, you could simplify this by just writing this as y equals 1 times x minus 0 is just x, and then if you add 0, that still doesn't change anything to your equation. So what I have down here is literally the same thing as this equation up here. I just simplified it. So this equation right here, y equals x squared, is what we call the parent function. So take note of that. So what I'll ask is, basically between two different graphs, what kind of shift, translation, we'll call it, or dilation, I'll ask you what it'll do as compared to this graph. So before we go on, why don't you guys open your graphing calculators, and we'll take a look at what that graph actually does look like. So I'm going to go to y equals, and I'm just going to put in x squared and hit graph, just to show you what that equation does look like. So it's just a U-shape, generic parabola. The first thing we're going to do is change the k value. So in the next slide, why don't you guys take down this equation and we'll talk about what it's going to do to your graph. So I'm actually going to keep my first graph on there, and in y2 I'm going to enter the equation that's on your screen now. So y equals x squared plus 3. Make sure when you put the plus 3 in, you went down from the exponent and it's not like y equals x to the 2 plus 3. The plus 3 comes after it, and we'll just see what it does. So my original function is up there, and it looks like it basically just takes that parabola and it shifts it up 3. So this value is going to shift, which we're going to use the word translate. It's going to translate the graph up or down. So in this case, it just took our last graph of y equals x squared, and the plus 3, all it did was just take all of your y values and it just added 3 to them. So if you think about, if we had a point on that parabola that was 1, 1, all it's going to do then, when you add 3, is it would make another point basically that would be like 1, 4. You're adding 3 values to your y coordinate. That's pretty much all it does if you have a value after the x squared, is it's going to translate your graph up or down. Similarly, the next one, I just took a shift of what's on the inside, so this would affect your h value. So we'll take a look at what this graph looks like. So I'm going to go back over here. I'm going to keep my first graph up there, and I'm going to put in this equation that's on your screen. So I'm going to open a parenthesis and put in x plus 2 squared. And if you guys kind of remember when we wrote these in vertex form, when we were dealing with the x values, it was like kind of the opposite on the inside. So when I hit this graph, watch what happens. It's going to create another parabola, but it's going to be 2 units to the left of the origin. So this is going to shift your h value, or it's going to translate the graph left or right, however many units this is. So again, since it was in the form x minus h, that's why the shift is to the left. So even though it says plus 2, it's going to shift it to the left 2. If on the inside of your graph you had x minus 3, what that would do is just take your parabola from 0, 0, and it would shift it to the right 3 then. So it would just take your vertex and just move it over 3 units to the right. Again, so it's kind of like the opposite on the inside, and it just affects your x value. So here's a shift of 2 things going on at one time. So this part right here is going to take your vertex and it's going to move it to the right 3 spots, and it's going to take your y coordinate of the vertex and it's going to shift it down 2. So what you're going to see on a graph then is a point at 3, negative 2. and that would end up being your minimum because it took it from 0, 0. So I'm making a prediction that my graph is going to look like this, and if I pull up my graph, -3, and then -2. And we'll see if we were right on the prediction. So again, I'm looking for it to be to the right 3 and then down 2, and there it is. So it's over 3, down 2, it just takes your vertex point basically. And that's all that we really look for as far as the h and k values. We call that a translation. The part that's going to make your graph like really stretch and get wider, or it'll shrink and get really small, that's that a value, which we're going to call a dilation factor, or you can even hear it sometimes called a scale factor. So this is going to be what's called a dilation, and this is going to take our graph and it's going to either make it really wide or it'll make it really skinny. So again, this is what y equals x squared looks like. So I'm going to go back to the graph, and now I'm going to put in y equals 2x squared just to see what happens. So there's x squared, and there's 2x squared. So it made it like really narrow. So that dilation factor, if it's greater than 1, it'll turn your graph a little bit more narrow. If it's between 0 and 1, which is the next example that I have, where it's still positive, but I'm making it 0.25, or you guys can say it as 1/4, but I can put in 0.25 x squared. Oops. And we'll see what this does then. So if it's a fraction, there's my x squared. It actually makes it like wider. So if you have a value right here for your a value, if your a value is between 0 and 1, and I'll make a note of this. So if a is between 0 and 1, the graph will get wider. And if a is greater than 1, the graph will narrow. So that's when it got like really skinny. When we had y equals 2x squared, the graph got really skinny, and when we had the 1/4, it just made it wider. So the next part to really think about is, what if I do all of these things? We'll take them one at a time, and the difference here is I have a negative sign out front too, and this is the last problem too, so this video is almost done. Yay. Okay. Here's my a value. Again, this is going to take my h, and this would be my k. So we're really looking at what is this 1 going to do, which is going to affect my vertex by shifting it to the right 1. And this is going to take my origin, well, again, the y coordinate from the 0, 0, from y equals x squared. It's a lot of words. And it's going to shift it up 4. So I'm going to have a vertex at the point 1, 4. And then my dilation here, that a value is -2. So we knew from last class that if it's negative, it's going to flip the parabola upside down. And now we know from this class that the 2 is going to stretch my graph out. So I can make a pretty darn good prediction before we even start that my graph is going to start over 1 and up 4. And it's going to flip downwards. And it's going to be a little bit more narrow than the last graph was. So that's a prediction of what it'll look like. So I'm going to go up here, I'm going to keep my original x squared still, and I'm going to type in this function, so -2, and then x minus 1, and please type this in with me too, +4, and hit graph, so it should be over 1, up 4. Oh boy, what did I do wrong? Poop. Go to. Oh, I hit minus. Make sure you hit negative. What a fool. No more errors. Sweet, there it is. So it went over 1, up 4, and then like I said, it made it go downwards because it was negative, and then since it's a -2, that's what made it go narrow. Now if it would have been like -1/2, then it would have made it wider, but it would still flip downwards. And basically that's section 12.7 in a nutshell. Like as far as like test kind of stuff goes, as long as you guys are able to explain what each of the little translations and dilations does, that's pretty much all we'll be assessing you on.